So like I mentioned in my previous video, we were talking about finding out the size of a network of a starting IP address and the ending IP address of a network based only on an IP address with the um, CIDR notation. All right. So based on that, you are in the real world supposed to give a proper answer when does this network start and when does it end. Sometimes it's easy, but sometimes it's quite hard. The problem with this concept here, with the /1, 2, 3, 4 until 32, the problem is that it is really user unfriendly. All right, you have to really be able to say immediately from seeing the number, let's say 15 or number, I don't know, 21, you have to immediately be able to say in which byte to which byte it belongs. In my opinion, it would have been a lot easier if we had this CIDR notation. This is a very, very simple one. This is a super simple. If they have, in my opinion, if they had used this CIDR notation instead of this one, it would have been so much easier. Even a second grader kid would have been able to calculate without any calculator immediately the network. However, they decided to go with this super complicated and useless, in my opinion, CIDR notation, which is /25. So my proposal would have been, of course, I'm not designing this stuff, but the most important thing in this CIDR notation is to know the size of the subnet. That's the most important thing. So you have to know how many computers are um, within this subnet. Are they 128 computers? Are they 64? Are they 32? Are they 16, 8, 4, 2, or 1 computer? How many computers are in this subnet, or how many units? Because if it's this one, if it's this byte, it gets multiplied by this and by this. All right. So in my opinion, it would have been a lot easier just to say 1.128. You would immediately know that the subnet contains 128 units and belongs to the first byte, to the first octet. That's it. So you can immediately calculate the subnet without any problem. If someone tells you going this logic 3.8, you know immediately, okay, it is in the third octet and it has 8 units in this subnet. This subnet contains 8 units. You know immediately what to do. So if they were using this method instead of this method, it would have been a lot easier for everyone. But with this one is like really, really not intuitive. It really makes things complicated. That's why very few people can calculate ranges, IP ranges based on the CIDR notation that we're currently using. So let's say, for example, we have this IP address 192, 168, 100, 100, and we have the CIDR notation, say, /20. Okay? With this, if we were using this uh, CIDR notation instead of 20, we say, okay, 20, it's stupid. We're going to use 3.16. We know immediately it's in the third byte and the subnetwork contains 16 units, right? Okay, so 16 units, all right? What happens here, you need to understand what happens if we have if we know that the network has 16 units. That means that the whole network, 256 units, gets split into smaller networks of 16 units. All right? Okay. So you can easily guess how many how many uh, how many networks are there? How many? Well, 128 are 2, 64 are 4, 32 are 8 networks, and 16 are 16. Let's see. Is it 16 times 16? 256. So 16 networks times 16 units within each network, with each subnet. Okay, cool. So you can start counting. You can very easily imagine this in your brain. Um, you have 16, 32, 48, 64, uh, 64. Then you have 64 plus, oops, 64 plus 16, 80, 96, 112. So you know, it's between 96 and 112. That's it. So this here is between 96, is within the network between 96 and 112. So this fits inside this bunch. So you know immediately that it is belonging to this segment of the 16 subnets that this byte gets split to. So super easy, 96, 112. So what will be the first one? What will be the first one? 192, 168 dot 96 dot 0 or 1. It depends or if you want to include the network IP address. I'm including it. And the last one is 192.168. They always remain the same. Dot 100. We go to the penultimate IP address. So we go to 111.255, which is the very last one before we hit 112. So it's that easy, that super easy. If we have the network slash 20, we have this slash 20, and this is the result. So with this simple method, with this simple um, seeder notation, I would call them seeder notations. They're just the relevant notations. You can immediately calculate this with your brain in your brain, even without a calculator, actually. All right. So you can always calculate the segments. You just need to know slash 19 is in the third byte, and it splits all the network, all the this octet into subnets of 32 units. And then of course, if there if you have 19 with 32 units, what do you get? You get, of course, from 0 to 32, from 32 to 64, from 64 to 98, right? Super simple math. And then from 98 to 128. So if someone tells you 100, this same IP address, but with a /19 instead of 20, you know immediately. Okay, you have split this part, you have split it into four 32 unit segments, and you can know, you can immediately say, oh, right, 100 belongs to this one. So first is 192, 168.98. Oh, sorry, 96. I apologize. I cannot. Sorry, 96, not 98. 96, and then the last one is 96 to 128. Sorry about that. So you know immediately, okay, this is 100. Where does it belong to? Here. It belongs to this network. So you have, this is 32, 32, 32, 32. The same is valid for the other ones. So like I said, this here would have been a lot easier for everyone if we had this instead of this here. But it is what it is. We have to adjust and try to memorize or to split it in, like in our memory, like from 1 to 8 is 1, 9 to 16, 2, 17, 24, 3, and 25 to 34, 32 is the fourth byte. It is what it is. That's what we're supposed to work with. That's how they created it. There's nothing we can do about it. Just wanted to have mentioned that. Thanks. Bye.